Now, comets do actually hit the Earth at times too. They think in an area in Siberia called Tunguska was a result of a comet that came in and exploded about 8 kilometres up in the atmosphere. The people in that area, which there's not very many, because fortunately there's not many people in Siberia anyway, but witnesses saw this huge blue flash go overhead. And then a few minutes later, there was a massive flash in the sky. The whole sky lit up. And then people 200 kilometres away, this huge wind came through, and people 200 kilometres from the impact were blown off their feet. So that would be like an impact hitting Ballarat, and you standing here, and when the wind comes, it blows you over all the way from Ballarat. That's how far away it was. But because of how remote it was, they couldn't actually send anyone in there until nearly 20 years later. So when they finally sent a mission in, about 1927 I think it was, the impact was 1908. 20 years later, this is what they found. There were trees laid out for miles and miles, all radiating from a central spot, like a huge crop circle. All the trees were flattened and they were all pointing away in the same direction. So this huge impact had pushed all the trees over, as well as people 200 kilometres away. So they do hit the ground. Fortunately, Comet McNaught didn't. It went past and we got a good view in 2006, 2007. Unfortunately, ones like this, they sort of happen once a year, but spectacular ones like McNaught might be maybe 2 or 3 in a lifetime. Hale-Bopp was only a few years ago, so we've probably only got one more left in our lifetime that might happen, unfortunately. But hopefully as impressive as McNaught would be good. Now they believe that the comets come from an area called the Kuiper Belt or the Oort cloud, which is speculated to be this is the orbit of Neptune out here, so way out past all the planets. I think there's this huge cloud of objects called the Kuiper Belt, and that's where a lot of these comets and things are coming from. It's about 100 times our distance from the Sun in diameter, so it's massive. You can see here, this is the orbit of Pluto. So Pluto is in the Kuiper Belt, but on the inner part, it actually extends much further out than that. So objects that are in this area are called Kuiper Belt objects, or KBOs for short. There's at least, they think, 70,000 objects bigger than 100 kilometres across. So lots of them out there, massive. Then we have other objects, similar, called trans-Neptunian objects, or TNOs. They're the ones that orbit, they don't actually come inside Neptune's orbit. So Pluto actually does get closer than what Neptune is, so Pluto isn't a TNO, but it is a KBO. So these ones never get closer than Neptune. Then there's Plutinos. Plutinos have orbits like Pluto. So they come perhaps inside Neptune's orbit, but they have one of these resonances. So every time they make no, I think I got this around the wrong way. They make 2 orbits for every 3 orbits that Neptune makes. I'll have to fix that. So again, Neptune comes along every couple of orbits, kicks them into their position. So they're actually under the influence of Neptune. And Pluto is under the influence of Neptune. It has this 2-3 resonance. Then we have scattered disk objects, SDOs. These are highly eccentric. So they might go all the way out to the Kuiper Belt at some time, and the other part of their orbit, they might come virtually into Neptune's distance. Now the one that we know of that's the furthest is one called Sedna. And Sedna's about this big compared to the Earth. You can see it's even smaller than Pluto, about half the size of Pluto. And it's the furthest object that we know of. At the moment on Sedna, compared to Pluto's orbit, Sedna's coming just around about its closest distance. So on Sedna at the moment, it's summertime. And by summer, that means it's warm enough that nitrogen, frozen nitrogen ice, can actually turn into gas. So it does get cold enough that there is no atmosphere. All the atmosphere just deposits on the ground like frost. It takes more than 11,000 years to go around once. At its furthest distance is about 1,000 times further than what the Earth is. And when it's at its greatest distance out here, the sun is about as bright as a quarter moon. So in the middle of the day, if you're on Sedna in the winter and you were to look towards the sun, you would see a tiny little star that's as bright as a quarter of a moon, and that's as bright as it would get on a winter's day. And it would be so cold that the whole atmosphere is frozen solid on the ground. There would be no atmosphere at all. The nitrogen would be ice on the ground. Now we have detached objects. Detached objects don't actually come in to Neptune's orbit. So they're so far away from all the major planets that the planets have no influence on their orbit at all. So even Neptune to them is irrelevant. They're so far away, the only things that affect their orbit are the other objects that are in this a similar orbit or something like that. Then as we go further out, we finally come to the Oort cloud. Now this is where they think a lot of the comets and that come from. It's about 1 light year across, or 1 light year in diameter. So light takes about 1 year from the sun to reach all the way out to the edge of the Oort cloud. And there's perhaps billions of comets in this Oort cloud, all waiting to perhaps come in at some time. Billions of them. There's no reason why our nearest star, Alpha Centauri, possibly would have a similar sized Oort cloud. The only difference is that Alpha Centauri has 2 stars, whereas we've only got 1. But there's no reason why it wouldn't have an Oort cloud similar to ours, which would be probably about 1 light year in diameter. So you can imagine a bit over nearly 4.5 light years apart, and each of us has this huge ball of comets that's 1 light year. So it stretches a quarter of the distance to the next star. And all the other stars possibly have Oort clouds just like this. So you can imagine all the stars in the skies have this halo of comets, billions of them. Except of course we won't ever see them because they're so dull and they're so far away. We can see the star, but we won't ever see the comets. So hopefully you can see that the solar system is a lot more than just planets, moons and the sun. You've got your dwarf planets, asteroids, Plutinos, comets, centaurs, Trojans, Greeks, Hildas, TNOs, Neos, SDOs, KBOs and DOs. Astronomers like their little acronyms. So there's all these different things that make up the whole solar system.